Assalamualaikum and a good day to everyone. Today I'll be presenting an innovation titled Potential Production of Biodiesel from Fish Waste of 3 local fish species in Terengganu, Malaysia. It is not a surprise that we are running out of fossil fuel. Seems like a common thing we hear, right? But do you expect it to happen the next 38 years? Because of the exponential rise of the world's population, the usage of limited fossil fuel has increased, thus resulting in a rapid decrease rate of the finished product. So, is it the end of the world? Don't worry, it's not. Instead, it's a chance for the human race to produce and innovate more sustainable products such as biodiesel. Biodiesel is described as monoalkyl ester of long-chain fatty acid, which is generated from renewable resources. Currently, more than 95% of the world's biodiesel is produced from edible oil such as plant-based oil. This may result in severe consequences of the world's food supply and economic imbalance. Using waste edible oil such as fish waste as a solution to this problem might be a viable option. So, what are the factors contributing to the spotlight given to fish waste? The main reason fish waste is considered as the source used for biodiesel production is because of its high rate of fish waste disposal in numerous industries. It is reported that approximately 60% of the total weight of fishery processing waste are not utilized and discarded. Keropok leko industry is seen to be one of the sectors contributing to the high disposal of product as only fish meat are utilized. In the keropok industry, the production of food product is known for its high usage of fish from different types of species such as Sardinella albella, Chirosanthus dorap, and Dicapterus macrosoma. This opens up an opportunity in the world of research to investigate the potential biodiesel production from fish waste of the 3 local species, filling up a gap in the research world as there is still no study conducted on the 3 particular species. A characteristic required in acquiring a high yield of biodiesel is to obtain a high yield of oil from the fish species. Therefore, fish species that have high content of lipid percentage would be more likely to obtain a higher percentage of biodiesel fuel. Another factor that promotes the production of biodiesel from fish waste is due to its highly variable oil content in processed waste. It can be seen that the percentage of oil content of fish waste is almost equivalent to some of the common raw sources of biodiesel such as rapeseed and palm oil that have the oil content percentage of minimum 45 to 50% as can be seen in Table 1. The discarded fish waste consists of viscera, head, frame, skin, fins, and scales. The head and viscera covers the most total weight with the percentage of 45% and 9.6% respectively. It can be observed in Table 2 that the head and viscera have the highest oil content compared to other parts, making them a potential major part in fish waste biodiesel production. Fish waste biodiesel also does not fail to show excellent quality of biofuel for our motor engine. The fatty acids consist of saturated, monounsaturated, and polyunsaturated fatty acid. The ratio of the 3 types of fatty acids is important as the percentages would aid in ensuring a normal reactivity of biodiesel on engine performance. Generally, the head and viscera of fish has the highest percentage of saturated fatty acids, followed by monounsaturated fatty acids. According to a report by the US Department of Energy, the perfect biodiesel would be made only from monounsaturated fatty acids. However, in Malaysia, biodiesel containing high percentage of saturated fatty acid is also acceptable as it would have good oxidative stability but poor fuel properties at low temperatures, which will only affect countries with winter season. Moving on to the question, so how do we produce the fish waste biodiesel? Well, generally, the production of biodiesel consists of 4 main steps, which are extraction, transesterification, purification method, and lastly, sample analysis method. In the first step, which is oil extraction method, a variety of processes including solvent extraction, wet reduction, and acid ensilage can be utilized. Among the three extraction methods, the wet reduction method is seen as the most suitable procedure to be utilized. Wet reduction method involves the fish waste being mixed with water with a 1 to 0.5 ratio and then heated in temperature-controlled water bath. After the dilution of fish waste has cooled down, the oil is then filtered, separated, centrifuged, and the amount of oil extracted is recorded. In the next step, the oil recovered from the fish waste is made to react with primary alcohol in the presence of a catalyst to produce biodiesel. The process is known as transesterification. The oil is heated in the oven before transesterification to eliminate any remaining water. Methanol will be added to the oil along with 1% of the weight of potassium hydroxide as a catalyst. Then, the mixture is heated on a hot plate with magnetic stirrer. After the transesterification process, the solution will undergo purification, which is one of the crucial processes. The process involves separation of glycerol and methyl ester, washing the biodiesel with warm distilled water, and lastly drying, which dries off the biodiesel from remaining water. The appropriate analytical technique for production of biodiesel of the three local fish species would be gas chromatography mass spectrometry due to the analysis being on fatty acid methyl ester composition. It provides a more definite qualitative information and biomolecule identification. From the general step of fish waste biodiesel production, it can be seen that the production is very low cost and uses simple instrumentation in the laboratory, easy to conduct, and also requires only short period of time to produce. Based on the study of the topic, the three fish species are anticipated to obtain significantly different oil yield percentages. It is hypothesized that Dicaptus macrosoma or ikan selayang will have the highest percentage of oil yield due to higher lipid content percentage of the species, followed by ikan tamban and ikan parang. It is also hypothesized that the oil content will display a compatible biodiesel that can be utilized in Malaysia with high percentage of saturated and monounsaturated fatty acids. The high quality of fuel could potentially lead to the utilization of the specific biofuel as a main source of biodiesel by future citizens of Malaysia. That is all for my presentation today. Thank you.